As a result of oil and natural gas being made out of hydrocarbons, today's focus is going to be specifically talking about what is a hydrocarbon and various properties regarding that. A hydrocarbon, once again, is made out of hydrogen and carbon. So a compound that is made up of entirely of carbon and hydrogen is considered a hydrocarbon. You can have 12 carbons, you can have 5 carbons, you can have 26 carbons, you could have an infinite amount of carbons. As long as it's just made out of carbons and hydrogens as elements, it is considered a hydrocarbon. Remember, hydrocarbons are the things that make up oil and natural gas. And what's really important about with hydrocarbons is the number of carbons. That defines all of its chemical and physical properties and behaviors. For example, if you had one carbon, meaning CH4. By the way, if you see C and then like H4, if you don't see a number like right after the element, see how there's no number, it is an understood assumed 1. So we're really saying for this one, we have 1 carbon and 4 hydrogens. Methane is the lightest, okay? CH4 is known as methane. It is the lightest and it floats. And what's really important with carbons is, or with hydrocarbons, is the number of carbons. If you have a compound that has 5 carbons or under, you are going to be a gas. This is where all of your natural gas comes from. So when you look for a pocket of natural gas, you know your carbon amount is between C1 and having a C5. Those are all of your natural gases. Okay, because it's a gas and that's the only carbons that can be in a gas. You need 1 through 5. If you have 6 through 18 carbons, you will be a liquid. And if you have more than 18, you will be considered a solid, or you will be a solid. So if I look at oil and it's a liquid, I know that its carbon amount is between C6 and C18. So let's look at some common hydrocarbons. If we look at these, what I want you to be able to do is identify how many carbons, what would its formula be, kind of things like this. So this guy right here is methane. If I count the carbons, I have 1 carbon, so I'd write C1. And how many hydrogens do I have? 1, 2, 3, 4. So this would be CH4, that is methane. This guy is ethane, which has C. How many carbons do I have? 2, and then I have 1, 2, 3, 4, 5, 6. So I have H6. That would be ethane's formula. Butane is C5H12. And then propanes, if I counted all these, you would get C3H8. Notice that all of these common hydrocarbons are between having 1 to 5 carbons, so therefore all of these would be a gas. So these are all considered your natural gases. Okay, so let's try to identify these, and what you're going to have to be able to do on the test is be able to identify, based off of the structure, what is its chemical formula, and therefore what is its state of matter. Okay, so the first thing you need to do for any of these is figure out what is its formula. So the black balls on here represent your carbon. So we're going to have C, and here's 1, 2, 3, 4, 5, 6, 7, 8. So it'd be C8H, and then you'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So H18. So if I look at it, remember, I really only care about that carbon amount. I have 8 of them. So what state of matter would that be? That would be a liquid. This one's a very easy formula to understand. You don't have to count anything. It's already given to you. This is C20. And remember, anything above 18 will be a solid. So this I would find as a solid. And this is a solid at room temperature, okay? So you can make it into a liquid by heating it up and melting it and things like that, but at normal everyday temperature, it would be a solid. And this one, if I count it, I have 1, 2, 3 carbons, so it's C3. I really don't care about the H's because I can base off of how many carbons I have, what state of matter it would be, but I'll do that anyway. So we have H, and then this would be 1, 2, 3, 4, 5, 6, 7, 8, so H8. And so that would be your gas because it had 3 carbons, which is between 1 and 5. All right, hopefully you kind of understand what's going on. Oh wait, I need to keep moving, sorry. All right, so where are these hydrocarbons used? Well, first off, they are used almost everywhere. If you think of what all the products of oil, that is where these are used, in addition to natural gas, because that's what they are. So hydrocarbons, where are they used? You see them in all these plastics. Okay, so anything that you have plastic that's made out of plastic uses oil, motor oil, diesel, gasoline. All of these use hydrocarbons. Okay, you look at these and here's your structure for gasoline. Here's your hydrocarbon amount. So you just count how many carbons. If you look at plastic, notice that it is a very long chain of hydrocarbons. So therefore that is a plastic. These are really hard to break down. Okay. All right, so thinking about all the properties that we've learned about, or the major property that we focused on, how do you think scientists can separate these compounds? Because when we dig it up as geologists or as oil companies, how are we going to separate them into that gasoline, that diesel, all that other stuff? How do you separate it? Well, because the main difference between them is based off of their number of carbons, which then translates to their boiling point. So the main way that we separate them, which we will get into a little bit later, is based off of their boiling point. And so we'll heat it up, and from the heating up process and boiling some of these compounds, they will able to separate into their individual parts. All right, I hope you guys understand this basically and have a great evening or day.